For today is a section on custom transformers. What are custom transformers? Well, these are sequences of existing transformers that have been converted or condensed down into a single transformer. And you can take any sequence of transformers in your workspace and compress them down into a custom transformer. So there's a few different uses for that functionality. We should chat out the link of where we are today, I guess. Diving straight in is all very well, but we should let you know where we're starting from. And again, any questions you've got throughout the day, please do ask Liz and post them into the chat window, and she'll do her best to answer, and I'll pick some out as well and answer them live as well if they're interesting to everyone. So yeah, please ask any questions, whether it's custom transformers or anything else you've learned in this week that you need assistance on. Anyway, so custom transformers, what are their purpose? Well, one of the purposes is to tidy your workspace. That's probably a lower priority now, but one of the things it can do is make your workspace less cluttered by condensing everything down. The main use really is to reuse content. So you have a sequence of transformers, you compress it down into a custom transformer, and that basically means you can reuse that sequence of transformers again and again in lots of different places, lots of different workspaces, lots of different projects, and it's very easy and simple to do. So reuse, obviously, if you've done any scripting or coding, you'll know how important reusing code is, and so this is really what we're doing here. And the other thing is within FME, there are certain pieces of advanced functionality that really only work inside a custom transformer. Parallel processing is one of those, and looping is another. So if you need your features to go through a loop and get processed again and again and again, then a custom transformer is a way to go for that. So that's what we're going to look at today. What we'll look at first of all is how to create a custom transformer. Let me see if I've got a workspace that I can do that in. Just going to look in my instructor workspace supply. So what have we got here? So I've got a set of transformers here that carry out various actions, concatenate some strings together, aggregate, which creates them into a group, and a string replacer transformer. So various transformers in here. It doesn't really matter what they are, I guess. So if I want to create a custom transformer, like I said, I can turn that sequence into an existing sequence into a new custom transformer by selecting those transformers, and then I can right click and choose create. I can do the shortcut, which is Control-T. Lots of ways I can turn those into a custom transformer. So I just right click, create custom transformer, and it pops this dialog up, and this dialog says, okay, well, you're creating this new transformer. What do you want to call it? And in this case, yeah, I could just call it my custom transformer or a training demo or whatever I like. And obviously, you'd usually give it a name that actually means something to what the transformer is doing. And you can give it a category as well. The category is the same as the categories in the transformer gallery in the navigator. So you have all of those listed that you can select from. So I could say, well, it should go under rasters or geometries or something. But I can also make my own category up and say, okay, well, this one's going to go into the training category. And we can put a title in there and transformer for demo purposes. And I can put information in a help screen and a history. So I can say, well, today's date is the 17th of May, 2019. It's me, and I created this today. So you get to put all sorts of different metadata in. And this is important because of where you can use the custom transformer again and again. And this information shows up whenever it gets used or whether you share it with other people. And so it is quite useful to have this information in there. So what I've done is I've taken that set of 3 transformers, I selected them all, I pressed Control T, I gave it a name, I click OK, and this is what we get. And you can see that I've got a new tab at the top of my workbench now. So before it was just Start, Main, and that was it. Now I've got Training Demo as well, because that's a custom transformer definition that I've got now applied in this workspace. So the transformer looks like this, the definition. It has input port and an output port. So this is where data comes in. This is what gets processed. This is what goes out. And if we go back to the main tab, you can see that the 3 transformers that were there before have been replaced by this green transformer object. And that is our custom transformer. So that's how you create a custom transformer. You can take any sequence of existing transformers, press Control T, and it turns them into this custom transformer. And as you can see, the main thing it's done so far is just clear our desktop up, clear up the workspace canvas. So, I mean, it just made it a little bit tidier. And really what you're trying to do is group together transformers that carry out a particular action. You're not really trying to just put all transformers together and put it into a custom transformer just for the sake of it. You're trying to make something that is a definite unit of processing, if you like. Now, once I've done that and I've made this custom transformer, can I make further edits? Well, yes, I can. I can just click back on that training demo tab, and I can start making edits in here. So I could say, well, that string concatenator concatenates creation instance, and I could add something to the front of it that says ID number. Oops, I'd have to, let's see, put a constant in there. Constant. So I could do things like this. So basically I can edit these transformers just as if it was any normal transformer, and that edits the definition. So now when the data comes through here, it picks up the definition from here, which has got whatever changes in that I felt like making. So it works like that. So that's creating, that's editing. You can create a custom transformer from scratch without actually having any contents in it. I can just right click anywhere and say create a new custom transformer, and we'll call this demo 2 and training again. I won't even put a description in, but I can create this custom transformer from scratch, and it has an input port and an output port, but that's it. So there's like nothing there, nothing connected up. If I want to, then I can start adding transformers in here. I can say, yeah, I want a 2D4, so then a clipper, like so, and so on. So yeah, so you can create a transformer, custom transformer from scratch and add the contents into it, but usually you'll make your transformers first, test them, run them, and then turn it into a custom transformer. So that's making a custom transformer. And it's how we edit one as well. And you can see what I mentioned when you talk about putting the metadata in. If I click on that training demo transformer, it shows up in the help and it says what it does, what category it's in, etc., etc. So it's very useful to set that. That doesn't look right. That looks like it's got the date in the wrong column. It's shifted everything across for some bizarre reason. Why would that be? Huh. Well, isn't that interesting? I don't know how that happened, but this session's recorded, so we'll look into that afterwards. Okay, so we have our transformers, and like I said, clicking on them shows them up in the help window. So like any transformer, it's very useful to to have that information. Now, one of the uses I mentioned was reusing this. So I'm saying, well, one of the main purposes of a custom transformer is to reuse content. And that is very easy to do. If I say, well, I've used my training demo transformer here, but I also have some data down below it, and I need to do the same thing here. How do I do that? Well, I just place another instance of that transformer. And so I can type the name in QuickAdd, and it pops up in the QuickAdd as well, training demo. Again, that's where the information comes in. It's got the category and the help info and description. So again, another reason for filling that information in. Anyway, so it turns up in QuickAdd, and I can just add a new transformer like that. I could even make a copy of it, just copy and paste within the same workspace, like so. So we can use that transformer and reuse it again and again and again within the same workspace. What happens then if I edit that? Well, if I edit that, then the definition is edited for all the places that it's used. So say I go back into that tab where I can make edits, and in one of the standard FME transformers in there, I change that and I say, let's assemble attributes only in this transformer. Whatever the edit I'd made, it doesn't really matter. Okay, well, it matters for the fact that that data isn't there now. Anyway, you get the point. I make some changes in here. Whatever the changes are, they get applied to every instance of this transformer. So that's another great advantage, because it means if I've got a sequence of transformers and I'm using them again and again, if I wasn't using custom transformers, any edit I'd make, I'd have to make in every different place. Whereas now I can just go into here, make my edit, whatever it is, in this one place, and back in the main tab, everything is updated in every location it's used. So it's reusing that code, if you want to call it that, again and again and again. We're just making changes once, and no matter how many times that transformer is used, the edits are applied in all of them. So let's have a go at exercise 1. There was a question: can I create several custom transformers in a workspace and call them from another workspace? Not really like that, but there are ways of doing similar things, and we'll look at that shortly, like as Liz said. But for now, let's get on and do this exercise. So let me just shut this window down. So what we have here is we have exercise 1, creating a custom transformer, and there is a beginning workspace to open up. So let's open that up. First of all, custom transformers, exercise 1, begin. So what we've got here is a workspace where a colleague has created, and they're calculating the population density for neighborhoods in the city of Vancouver. So we can run this transformer and run this workspace now. I've got feature caching turned on, so let's see what happens when we run. So I can see in the source data there is a population for 2001 and a population for 2011. That unexpected input's fine, we can ignore that. So we've got the population as an attribute. We're just doing a bit of tidying up with attributes and reprojecting, and then we're calculating the area of that feature of each neighborhood. And then we're doing an expression evaluator, and the expression evaluator calculates the population density for 2001, which is the population of 2001 divided by the area. And then it calculates the same thing for 2011 using the 2011 population. So really all it's doing there is calculating the area and dividing it by an attribute, calculate some density values. And that's great, but you and your colleagues say, well, this is a pretty good project. We could actually turn this into a custom transformer because other people might want to calculate density throughout our organization. So if we turn this into a custom transformer, then it'll be easier for us to do it again and again, and easier for other people as well, which we'll see shortly. So I've run the workspace, I've seen what it does. It creates, we've got neighborhood Kitsilano, there's its two populations, there's its area, and this is the population density. So in 2001, it was 7,200 people per square kilometer. In 2011, it's 7,500 people per square kilometer. So we got a denser amount of people. So more people in Vancouver, which is not surprising. So what we're going to do now is create this custom transformer. And the two key components for that are the area calculator and the expression evaluator. Why is that? Why not the rest of it? Well, when you think about it, we're cleaning up some attributes and we're reprojecting the data. But not every time you calculate density are you going to need to reproject the data. That might only be in this case because we're using a KML data set that's in latitude and longitude. Another time we might be using something in a different coordinate system that we don't need to reproject. So we're going to leave those transformers out of our custom transformer. We don't need what they're doing in our custom transformer to be reused again and again. What we need is the area calculator, and what we need is the expression evaluator, but we only need one of them because they're both doing the same thing, and you'll see how this works shortly. So I've selected both of those transformers. I'm pressing Control T, and now I have to give it a name. I'm going to call it the density evaluator because there's already a density calculator. It does something a little bit different, which is why you might need this. But anyway, we'll call it density evaluator or call it whatever you like. And we can give it a category. Again, I'm going to call it training, or actually does it say what to use? No, it just says use a category. So I'm going to click the drop down and say calculated values. That's a good category for it to go into. We can put a little description in there as well if we like. And we can edit all of this later. I'm not sure we can edit the name, but we can certainly edit the description. So this just needs to be very basic right now. This transformer calculates, see, I even spelled that wrong. That's okay, I can come back later and fix it. Calculates density using an attribute and an area size, like so. So we can just do that. The markdown option is when you're sharing this transformer on the FME hub, which again, perhaps we'll look at that later. I'm not going to do that now. So I click OK with those two transformers selected, and that's what we've got. We've got our area calculator and our expression evaluator. So let's have a look at that custom transformer. We've got the area calculator input. You can see that FME's renamed these ports automatically to say what it's coming in and out of. If we go back to the main tab, and you'll see this transformer here, you'll see it's got parameters just the same as any other transformer. If I click on that, it pops up and says, oh yeah, you're picking this attribute. So why it's done that is because within the expression evaluator transformer, it was using this attribute called total population. So what it's doing is it's prompting for that, and you'll see why it's doing that shortly. We'll get into that in more detail. So now all we need to do is run this translation and just to prove that the results are the same as before, which they seem to be. So we've made a custom transformer, but we haven't affected the operation of the workspace. So we are pretty much all good right now. So it's to save the workspace, which you can do or not do. It doesn't really matter too much. But what we've learned there is how to create a custom transformer from a set of existing transformers and how to handle attribute references automatically, which is the default setting. So we didn't even need to do anything about that. So hopefully you got through that fairly quickly. All it was selecting two transformers and pressing Control T, so it shouldn't have taken too long to do that. Okay, so a custom transformer, like any normal transformer, a custom transformer has a set of input and output ports. When you create the custom transformer, those input and output ports are named according to what was connected to it at the time. So going back to our example we just did, the exercise, it's connected to the area calculator input and the expression evaluator output. So that's what the ports are called. And you'll see the transformer in the main canvas has those port names listed like so. But they are quite lengthy names, and we probably don't want to keep those names. So what we can do is rename those. Now let me open up another one of my instructor workspaces. And let's have a look at some of that. So what we have here is a raster processor transformer. Basically, we don't have any ports in there yet, which is odd, but let's go have a look. So we've got some we've got a custom transformer, we've got regular transformers in there. We don't have any input and output ports. They must have been deleted. So what we can do is we can right click and choose insert a new input. And by default, it's called input. And I can right click and choose insert transformer output. And it's called output, and we can connect that up. And now the data is flowing through our workspace. And if we go back to the main tab, you can see it's got an input and an output port. And what we're doing here is we're overlaying parks onto a raster data set. So I added those input and output ports, and they were just called input and output. So what was the point in that? Well, I mean, that's okay as a basic one, but what input's coming into there? Is it going to be the raster data, or is it going to be the parks data, or is it going to be both of them? I don't know. So what we can do is we can rename those ports to be a bit more relevant to what's going on. So for example, if I go back to that tab, I can click on the object, I can press F2, or I can right click and rename, and I can change this and give it a name. And often I would give it a name that's related to what I'm expecting to be input into this workspace, into this transformer. So that's connected to the area builder. So we're going to say vector features. I'll just call it vector. So I can rename the input port to just be vector. And you can see the raster is not connected yet. So I need that to come from somewhere. So what I'll do is I will create another port for the raster. I guess what I could do is have everything come into this input port and then try and split the vector from the raster separately. But in a transformer, you'll see that it's more common to have different input ports that have got the proper name. So again, I'm going to add a new port. I'm going to right click, insert transformer input. I'm going to call this one raster and connect that up to the raster input like so. So you can see we can have as many input ports as we like. I go back to the main tab. There they are. We've got vector and raster as the input. So now not only can I connect them both up, but it's more obvious to me what that needs to be connected. It's not like they're called port 1 and port 2, which would mean nothing. They're called vector and raster. We even have an output port. Do we need any other output ports? Well, maybe. I noticed there's rejected data ports on all of those transformers. So maybe what we could do is we could right click, insert a new transformer output, and call it and add a rejected port. A lot of transformers have got a rejected port. You can see in here, I can create a similar thing for my custom transformer. And if I give it the name with the less than sign, basically within a tag, if you want to call it that, so less than, rejected, greater than, as long as I give it that name, then it will act as the same as a rejected port in all of these transformers. You'll remember that if a feature comes out a rejected port, the translation will stop. And that will happen with my custom transformer as long as I give it the same name. I believe that should work. So I've got an output port and a rejected port, and I can just run this translation and see what happens. And so I'm reading my raster, I've read my parks, I'm overlaying one on top of the other, and that's pretty much it there. But hopefully you get the idea that you can have input and output ports, and you can rename them, and you can have as many ports as you like for whatever input and output you need. And if we just look at this output, we should see it is the raster data with the parks data overlaid on top of it. When I say overlaid, it's actually stamped into it. It's not vector anymore. It's been sort of stamped onto the raster, rasterized and added together, if you like. So the parks are now part of that raster data set, like so. So anyway, that's what the vector on raster overlayer does, in case you were wondering. But the more important thing for us is what's going on with custom transformers and input and output ports. Okay, there's some questions on the bottom of this page I'm on right now. Which of these is a reason not a reason to use a custom transformer? And the answer to that, I happen to know, is to make my content available in Quick Add. I mean, it does do that, but it's not a reason you need to do that. You don't need to create custom transformers just so you can add content in Quick Add. What you're using it for is to do things like looping and reusing things and to tidy the workspace. And I don't know if anyone's tried this other question there. If I select those 3 transformers and create a custom transformer, how many input and output ports does it have by default? So by default, what it will create is the same number of input and output ports as it has input and output on these transformers. So on this, I've got one transformer coming into the length calculator, one connection going into the length calculator, one connection going into the area calculator. So that will give me 2 input ports. And the statistics calculator, although it's only a single transformer, it's got 2 output ports. So 2 output connections. So I will get 2 output ports in a custom transformer. So I think it's 2 inputs and 2 outputs. And yeah, that's correct. So it's not, when you generate a custom transformer, it won't necessarily just have 1 input and output port by default. It will create as many input and output ports as are needed for data connections coming into and out of that transformer. Okay, exercise 2. Let's go back and do some more practical work. So again, we're carrying on with the previous exercise, as we often do, and we've got our density evaluator transformer, and it's got some very long port names there. It's got our area calculator input and expression evaluator 2001 output, which is not particularly useful for us. It just makes the transformer a bit long. So we're probably going to rename those, I suspect. Okay, so let's open the workspace up. If you didn't finish the last exercise, just open up the starting workspace for this. First thing it says is, well, we started out with 2 expression evaluators and now we've just got the 1. So why don't we duplicate our existing transformer to handle that? So I can click on that expression evaluator, press the delete key to delete it, click on this transformer, press Control D or right click, duplicate, and create a second instance of it, like so. And we are going to connect these up in parallel for a reason that you'll see shortly, but later on we'll connect them back into a series of one after the other. So for now, we should have something that looks like that. We just duplicated, placed a new instance, if you like, and that's probably a good word to use, as an instance. We placed a new instance of that custom transformer. Now we place that new instance, but it's going to be doing the same thing right now because we've not told it to change anything. So if we look at the setting for that first one, it says analyze the 2001 population. So we can go and click on the settings for the other one and say, actually, we want to analyze 2011. It's a different one that we're running on. And now I can even run this translation just to make sure it's processing the right stuff. Are we getting two outputs? Well, let's have a look at this. Population density 7236 and population density here 7556. So yeah, we're getting the right results. Now the one problem is that they're both putting out an attribute with the same name. So they're both calculating something that goes into an attribute called population density 2001, and the same with this one as well. And that's obviously not that useful for two obvious reasons. Well, three reasons actually. One of them is it says 2001 when one of them should be 2011. The other problem is that if they both got the same name, how do you tell them apart? And the third problem is we're trying to make this into a generic solution, and that's not really much of a generic solution if it's called population density. Another time I might be calculating the density of something different. So to output an attribute called population density is not very useful, not very generic. So let's fix a few of those problems, and we'll also fix up the ports as well, because the port names are a bit too long as well. So we click on the tab to go back to the custom transformer, and we'll look at the definition here. And all we're going to do is look at the expression evaluator. We're going to click in there, look at what that transformer does, and we're going to change the result or the new attribute from being population density 2001. We're going to call it density result, like that. And we could change the name of the transformer as well, although I don't think it's really necessary. It suggests to in the manual. So let's do that just because it says to in the manual. So really all we're doing now is putting something into a density result, which doesn't mean things aren't going to get overwritten, but it makes it a bit less, it makes it more generic for us. And you'll notice in here it says 2001 population divided by the area. Should we change that to 2011 as well, or how is that working? If we're sending data in from both of them, how can we set it to both? Well, luckily we don't need to, and again, that's something we'll look at shortly, is how we handle these parameters when you duplicate a transformer like this. So we just change that name, and now the other thing we're going to do is change the name of the input ports. So I'm just going to change the name of the input port there to input. And I'm going to change the name of the output port to output. Again, you can click the parameters button. You can probably right click and rename. You can press F2. Any one of those will be okay. But we're just going to use input and output for now, I think, because that is a more generic way and it's simple enough. I don't think there's anything. I guess we could say instead of the input port, we could call that polygon, so that the user knows. If anybody uses this transformer, they're going to know it's expecting a polygon feature or an area feature. How do I know that's the case? Well, because it's passing it to an area calculator, so that's pretty obvious. So I can do that and say, actually, let's call it polygon and output. You can call it input and output. It doesn't really matter. Well, we're just trying to demo a few things here. So back on the main canvas, we can see that the transformers have been renamed. If we run this workspace, I'm going to do a rerun entire workspace because things are cached. In fact, we might turn caching off because caching sort of gets in the way a little bit of debugging a custom transformer. But anyway, so yeah, so now we have a density result value, and For Kitsilano in 2001, it was 7236, and Kitsilano in 2011, it was 7556. So we're getting the right results we need now for that data. So hopefully you're all up to speed on that. So yeah, so what we did there is we just went into there, we changed the expression evaluator to create a different name just to make it more generic, and we changed the names of the input and output ports. Okay, back to my content instructor stuff. So let's have a look at parameters and parameter input. A lot of transformers, somebody's asking, can we make the results 2001, 2011 separate columns? Yes, we can, and we will do that very shortly. I will show how to do that. Someone else is getting an error message that I think Liz is going to have to look at for us. So I'm going to go on with this part. So yeah, so like I mentioned, a lot of transformers, you can put a value into a parameter, but you can also use an attribute to supply a value to the parameter. If I open up one of my instructor workspaces, let's see, schema handling, this is the one. So, I mean, let's have a look at some of these transformers that I've got in here. Like I've got this label point replacer here, for example, and the height is set by a fixed value, and the label is coming from an address ID attribute. So if I run everything up to that point, oops. Okay, I don't want to run that bit. I just want to caching turned on. That's interesting. Okay, I'm just going to delete that for a second and then run this. So what's happening here is we're taking that from an attribute, and if I look at the labels generated from here, it'll have taken the value of the address ID and used it as the label that it's printing. So that's just an example of how a transformer, which has its own parameters, can take a parameter from an attribute like address ID, and it can also have a fixed value. And in this transformer, we're actually taking it from a published parameter, user parameter, which you looked at yesterday. So we have user parameters can also supply a value. So that's how that works. Now, what happens if I turn that into a custom transformer? Well, let me run that first and set these published parameters. So we'll go with postal code and the label height. Again, I can just type something in of 10. So I'm just running this workspace. So, okay, let me turn this into a custom transformer. So I'm going to turn this one first into a custom transformer. I'm going to call it test 1. Okay, let me see. Right, so what I did, I turned that transformer into a custom transformer, and the label point replacer was asking me for these user parameters. So how do I set them now? Well, how I set them is by clicking on here and looking at the transformer parameters dialog. So it's not asking me for a user parameter here. The user parameters are, once you put them into a custom transformer, they become available on this transformer itself, but they're not published. It's like you're taking those user parameters, those published parameters, and sort of putting them into the custom transformer definition with the content that you're adding. So if I hit the run button, it doesn't prompt me for any values. If I run this, it's not prompting me for any values for that transformer. Why is that? Well, because they aren't published parameters in my main tab anymore. They're published parameters in the custom transformer. So think of published parameters that you looked at yesterday. When it comes to custom transformers, you got to think of them as two separate things. You can either publish the parameters in the custom transformer definition, and they'll appear on here. And at that point, you can publish them on here as well, and then they would be prompted for. So you can publish the same thing twice. Like if I say create a user parameter from that, now it will prompt me for the height of the field, which I type into there, gets added to that parameter gets passed through to the parameter in the custom transformer, which is where it's used. So user parameters and published parameters get put at two different levels, if you like, one inside the custom transformer and one on the main tab. So just to demo that again with, well, that was user parameters that we were handling there. Let's look at attributes as well. How are they handled? Well, they're handled in a very similar way. Let's look at this transformer. It's got address ID being used for the label and a label height fixed value of 10. So if I make that a custom transformer by pressing Control T, I'm going to call it test2. The key setting on this dialog is the one down the bottom that says handle with published parameters all of your attribute references. So in other words, if you've got a parameter that's referencing an attribute, it's going to create a user parameter or published parameter for you to tell the custom transformer what that is. Hopefully this will make sense once we try it out and I show you. So I'm turning that transformer by itself into a custom transformer. If I look under published parameters, oh look, it created a parameter automatically for address ID that was being used from an attribute. If I go back to the main tab and click on its dialog, oh look, there it is. So in other words, the capability to set the value as an attribute has moved into the custom transformer. So the custom transformer automatically said, well, I'm going to create a parameter to prompt you so that you can carry on selecting a different attribute in here to do what is necessary in your workspace. So whether a parameter is set by an existing published parameter or an attribute value, whenever you turn that transformer into a custom transformer, FME automatically creates user parameters in the navigator window in your custom transformer so that back on the main canvas, you can carry on selecting values for that, or whatever parameters were in there. So that's how that is all handled. And again, I'm not sure if I'm explaining it really well or not, but again, once we get to use that a little bit more, it'll become a bit more easier to understand what's going on. But the way I find, again, to understand this is to say, well, I used to have user parameters or attribute references in my canvas. They've been moved down to a lower level now, so into the custom transformer. So FME created more published parameters just to let me have that same capability as before. And that all comes about because, like I said, we are using this option here when we create a custom transform to say handle this with published parameters. Now the other option on there is fix manually, and the question in the manual says, what would happen if you didn't use handle with published parameters and you used fix manually? What would happen? Well, what would happen is the workspace won't run by default because no attributes are available. That's true, because if I don't, let me undo that. if I go Control T on this, create test 2 and say, let's handle that manually, none of the attributes become available inside the custom transformer because there's no way for me to pass them to there. I didn't create a parameter. I can't tell the transformer which attribute to use, so it's turned red. So that's one problem. There's no way to pick attributes from the main canvas. Well, I've seen that. I can't go into this dialog and pick attributes now. Before I run it, I'm going to have to fix that. And the way I'm going to have to fix it is manually exposing those attributes somehow, which I can do. I can just put a check mark here and say, actually, I need address ID. But I've got to do that manually. FME would normally do that automatically. So that's true. And the other thing that's true is it won't work on a different schema. What do I mean by that? I mean that if I have some other data in here, like zoning data, that's in map info tab, which doesn't make any difference really, but I'll mention that. So I've got this other data set here of zones. If I pass it into there and say, actually, I want to create a label, or not even that, say I reuse that transformer and say, oh yeah, I want to create my label from the zoning ID. Well, unless I manually did that, and I did make that change. So now I can use zone category. But before I made that change to expose that in the custom transformer, it wouldn't work on a different schema. So all of those are true. So if you don't use the automatic tool, then it becomes very difficult to reuse your custom transformer. And again, just let me demo that. I'm going to just undo all this again, just to show you one of the key drawbacks about, or one of the key benefits from using automatic. So if I go into this transformer, I press Control T, I call it test 2, and I make sure it's handled with published parameters automatically. What does that mean? Well, it means I can reuse that transformer in different places. Currently, it's using address ID to create a label. If I place a new instance of it somewhere else and say put it on zoning, I have that parameter available to change it to zone category instead. So by using that automatic capability, it's a huge benefit for being able to reuse that transformer in different places. And I think I showed you as well. Let's see. Okay, yeah, so if I look in here, look in my transformer definition and put another transformer in here, like a string concatenator, and say, because I can make any edits I like inside here. If I put a string concatenator in and say create this result, and it's going to be this attribute, and it's going to be the address ID, and another attribute, and it's going to be postcode. It's like, oh, I can't see postcode. Why can't I see postcode in there? I want, like, if I look on the main tab, postcode is there, but when I look in the definition, it's not here. Why is that? Well, again, that's because of where you might reuse it. The key is, well, if I reuse it in different places, I've got to make sure that attribute exists in different places. So what I can do is I can come back to my definition and say, click on the input port, put a check mark against the postal code. Now it becomes available and I can use it in the string concatenator. But much more than that as well, it also created another parameter for that called postal code. So when I go back to the main tab, oh, excuse me, my phone obviously ringing. Where were we? Yeah, so when I exposed an attribute in here and said I now want to use postal code, it automatically added it as a user parameter. So back on the main tab, where I reuse the transformer here on test 2 on the zoning data, again, I don't have postal code, but again, I do have a parameter that I can say actually use zone name instead. So really that section was about, well, what happens when you use, someone really wants to get in touch, excuse the phone again. Again, the key is what happens if I reuse the transformer in a place that has a different source schema, like this. So I've used test 2 in a place where we've got address values, but if I use it in a place that's got zoning values instead, zoning attributes, how can I do that? How can I make sure I can use that transformer in different places? Well, it's by publishing that parameters, which FME does automatically. And if you expose them in here, then again, FME will add a publish parameter for you. That means I can come into here and say, yeah, I'm going to use different attributes here. So this is another way to make sure that it's reusable. Okay, let's see. Let's go back into our exercise and carry on, and we'll do this exercise, and then we might think about taking a break. So we're going back into the previous exercise, the previous workspace, where a custom transformer calculates density of some number for a particular area. So it works, but we want to make it a bit more generic, and we want to expand its capabilities as well. The transformer was created using an automatic schema handling. So that means that a lot of that's handled automatically, so we don't have to worry too much about that. But there are improvements we can make. For example, if I look in the parameters, it's asking me what attribute do I want, but it's got a label of total population 2001, which really isn't that helpful in this case. So what we need to do is sort that out and make it a bit more generic. I've just chatted out the link to the exercise. So open up your previous workspace or the starting workspace for exercise 3. Notice that there are currently 2 instances of the transformer, and both of them produce a result, an attribute called density result. Well, it would be nice, and somebody mentioned that earlier, if we could just use one transformer or 2 transformers in one after the other to give different values to different names. Like, I can't specify the name that's being created in the output, and it will be really useful if we could do that. Excuse me. Excuse me there. So let's click on the tab to go back to Density Evaluator and go back to the definition and inspect the parameters for this expression evaluator. The new attribute is called Density Result. We set it manually. Wouldn't it be great if the user, whoever was using the custom transformer, could do that by themselves and give it a different name? So what we're going to do very much like you did yesterday, click the drop down arrow, use a parameter, and create a new user parameter, like so. So we go into the transformer definition, go into the expression evaluator settings, density result, user parameter, create a new user parameter. The prompt is going to be new attribute, and the default value is going to be density result. That's fine. I don't think we need to change anything there. Click OK. And what that does is we've made it into a published parameter, so it should have added that as a published parameter in the navigator window, which I can see there. And coming back into the main canvas, we can see now that we get the choice to set it by ourselves. So density result. So what that means is now we can make that second custom transformer come in the same stream of data as the first. And in the first one, we'll say use the total population in 2001, call this density result 2001. And in the second one, it's calculated from 2011. Therefore, we're going to call this density result 2011, like so. And we sort of jumped through a few hoops there because really we could have just done this to start with, but we did it this way, doing it in parallel first and then changing it, just so you can see the different steps that are needed when you're putting a transformer together like this. And now if I run this, instead of getting 12 features out, which wasn't really the ideal, we get 6 features out, but they should have 2 different values: density result 2001, density result 2011, and they're 2 different values, so we know it's working fine. So, and again, this is making things more generic. It lets the user, it asks for a new attribute. We can set whatever attribute we like. The user can set something. It just makes it a bit more easy for them to use and a bit more generic. So at first glance, it might appear that we're now back where we started from, and that's true, we are. We're running a workspace that's creating 2 different density values depending on the population density and population for each year. So we're back to where we started from. But the important part is we've now got this solution that will work in other scenarios. We've got this density evaluator custom transformer that we can use in different projects, and we can use it again and again inside this project as well. We could give it to other people, as we'll see shortly, and let them use it in their projects. So that's the advantage of where we've got to now. We've got a totally reusable and generic solution to calculating density now. Okay, so if we go back into the prompts again and look at that, the prompt for the attribute to use is just says total population 2001. Why does it say that? Well, because that's the attribute we were using when we created the custom transformer. So that's the label that FME gave it. That's not really a very generic attribute or prompt. So what we can do is, again, we can go back into the evaluator definition. We can find the published parameter that FME created, total population 2001 it's called. We can right click that. We can choose edit definition, and we can change the prompt to be from that to attribute to analyze. If I could spell analyze, there we go, like so. Now, the problem is we change this parameter, it changes it in every location that custom transformer is used. And so when it's got the default value in there, that's the one that's going to be used in different places. It's going to be used in the same place. So basically, if I click back to the main tab and look here, it says, what's the attribute to analyze? Total population 2001. If I look in density evaluator 2, oh, actually it worked. It didn't change the, I thought it would change that to default to 2001, but it didn't. So doesn't really matter, I guess. That seemed to work. It didn't work when I put this exercise together, I'm pretty sure of it. So anyway, so there's an extra step to jump through in step 2, but it seems that you don't necessarily need to do that. But I'd advise checking the settings here just to make sure you're picking the right attributes. But again, you can see this is more generic now. It says, well, what's your attribute to analyze? What's your new attribute? We could call it result attribute or whatever we want. And it's working okay. So yeah, that bit with the FME lizard says we can probably ignore that because it seems to work okay there. Well, it worked okay for me. Okay, so we've got that far. We've got our reusable thing for calculating density, and it works in our example and we're happy. What we might say now is, well, wouldn't it be great, because we're going to reuse this in different projects, wouldn't it be great if instead of calculating, because it's calculating here people per square kilometer, but that might not always be the case. We might be calculating for different areas like trees per square meter in a park or something like that. So how are we going to do that? How are we going to give it different units? Well, let's go into the definition and make those changes that we need to do just that. So we've got a solution here, but we're improving on it just because we can, and it will be useful in different areas. Okay, so go back to the custom transformer definition. And what we're going to do is we're going to let people choose what units they want. Well, if we're going to make them choose or let them choose which units they want, that's going to be a user parameter. And we're going to create that user parameter inside the density evaluator, because that's where we're going to make use of it. So in the density evaluator, look for user parameters in the navigator window, right click, create a user parameter. See this, again, going back to yesterday, this is why these transformers, published parameters, sorry, is so useful, because you do use them in custom transformers quite a lot like this. It's not just setting values for the user to be prompted for at runtime. When you start creating custom transformers, published parameters become really important then. So we need to ask the user what units they want. We could make them type it in, but obviously a better way of doing this will be to do a choice. So we are going to say, actually, we're going to do choice with alias. We're going to be sort of smart about this, and you'll see what we're going to do in a minute. We're going to create this parameter. I'm going to call it density units. It's not an optional one. The user has to choose it, so we're going to turn off the optional setting. And the prompt is going to be just boringly density, yikes, density, oh, good grief, dentistry units, dentistry units, should be density units. I can never seem to type when I'm in a training course, just my typing goes weird. Okay, so we set the choice parameter. We haven't set the configuration yet, so we click the browse button and we get to this pop-up dialog that lets us enter the definitions. So we're going to put square meters, and the value of that is going to be 1. So this is a choice with alias. So the user is going to see square meters and square kilometers, and but the value that's going to be supplied to FME is one of these. It's going to be 1 or 0 point and 5 zeros after the decimal place, 1, like so. And if we wanted to, and if you're in the US or a different country where square feet were used, and in fact, since we're making this generic, we probably should do that. We can say square feet. I'm trying to remember how many square feet are in a square meter, which I should know because I used to be a land surveyor. So that's square meter. I'm just Googling it in my web browser, 10.7639. So I'm going to go with 10.7639. And I guess I could also do square yards as well. This isn't in the manual, I'm just sort of making this up as I go along. 1.19, I sort of knew that one, I think. 1.19599. So I'm going with 4 different units, but for you it doesn't really matter here. And those are just the fractions of those compared to a meter. And we can click our default value if you want to set a default to square meters. There we go. And oops, sorry, I should have, luckily I can go back and edit the definition. Under attribute assignment, I'm going to turn that off because I don't want the user to be able to supply that as an attribute. And you saw that yesterday, I hope, that if you turn that off, it stops the user picking an attribute. They can only pick one of my choices. Okay, so I've got those choices that the user's supplying, and it's supplying me a number. Where am I going to apply that number? I could apply it in the expression evaluator, I guess, but I can also supply it in the area calculator. The area calculator has got this multiplier parameter, and if I multiply by 1, then that's square meters. If I multiply by blah, 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 it's square kilometers. So all I'm going to do is say, instead of using that value, use my density units parameter instead, like so. And now if we go back to the main tab, we should be able to find that these transformers not only have this new attribute, but we can set it to any one of those 4 values. And we shouldn't be able to set it to an attribute because we told it not to allow that. So I can change that to square meters and this to square meters. Someone was asking why there's 2 different transformers. Because each of those transformers is calculating a different density for different years, if you like. I guess in reality, you might only use one density evaluator transformer, but in this case, we've got 2 different population sizes for 2 different years, so we're going to use 2 different transformers. We can use 2 attributes to write them out to different attributes in our output, like so. So if I run this translation now, we should find that instead of getting people per square kilometer, we're getting people per square meter. So there's like 0.07 person per square meter in Vancouver. So, or in the west end of Vancouver, whatever area that was. So again, that doesn't really make a lot of sense in this case, but we're trying to make this transformer as generic as possible. So for example, what I might do is add my parks data in here. Because if you'll remember the parks data, and I'm sort of going off road a little bit here, but I'm just sort of showing why we do what we do. If I add the parks data in here, notice that it's got a tree count and a visitor count. So I could say, well, let's put another density evaluator down. The parks are polygons, so that's okay, that's connected up. The attribute we're going to use is tree count. We're going to write it to an attribute called tree density. And we are going to do it in square, we'll do square meters again. How many trees per square meter are there? And if I run that now, not only am I going to find out the population density for each different area of Vancouver, I'm going to find out the density of trees per square meter in the parks of Vancouver. Or I could change it back to square kilometers, which would make more sense. So, like so. So now I know that T Swamp Park, whatever that is, has got 760 trees per square kilometer and 3,022 square trees per square kilometer in Strathcona Park, and so on. And again, notice I didn't need to reproject that data, and that's why we don't include the reprojector in our custom transformer. We've got an advanced exercise. I'm not going to do that here because we don't really need to worry too much. One of the things I did notice is that these custom transformers output a value called neighborhood area, which I didn't really. Let me have a look. Let's go back to this definition. And if we look at what attributes are coming on the output port, oh look, it's sending out an attribute called neighborhood area. So do I really want that? So that's what the area calculator is creating here, is an attribute called neighborhood area. Do we really need that? So there's a few different things we could say here. We could say, well, we're calculating that value, so we might as well provide it to someone. We shouldn't call it neighborhood area, but we could call it polygon area. Or the other way of looking at it is to say, well, maybe we shouldn't be even outputting that at all. And if we click on the settings for the output port, I can actually say, don't output everything, just output the specified ones, one of which will not be neighborhood area. We don't need the neighborhood area to come out of there. So we wouldn't get neighborhood area out of this transformer anymore. The other thing we don't really need is total population 2001, because again, that's not necessary. So I go back into my custom definition and turn that off. So all I'm getting at is density result plus whatever set by val. Okay, so that's the same thing, I guess. That's the new attribute. Let me go back to here. Tree density. Yeah, I think that one is just, we don't need to worry about density result. I don't think that gets output anyway. So there we go. That shouldn't output that now. Anyway, you have this choice, and other ways of doing this is quite often you generate temporary attributes inside a custom transformer. So often what I do is I prefix it with the name of the custom transformer. So I say underscore density, here we go again, density evaluator underscore neighborhood area. And then I put an attribute expression remover or bulk attribute remover, and say, please remove anything that starts with underscore density evaluator. So this is just another way of doing a similar thing. It's like saying, well, any temporary attribute I generate in here, I'm going to tag with my custom transformer name, and then right at the end, I'm just going to get rid of it. And that way, we know it's not going to come in the output as well. So that's another way of doing that. All sorts of different ways you can handle what comes out of the custom transformer. Okay, so we've been going for a while now, so let's take a break. We are going through this at a fairly good pace, I believe. Custom transformer types. Okay, so yeah, so what we'll do is we'll take, say, a 15-minute break. And if you want to have a go at the advanced exercise that was part of the exercise that we just did, that's fine. Please do have a go at that. That's using a weighting function for the density, which again will be a good thing for a density calculator, evaluator, but we don't need to cover it in here. So let's take, say a 15-minute break. We'll start again at 10:28 on my clock at the bottom. So yeah, so grab your coffee, check your email, do the advanced exercise if you would like, finish off the exercise, the basic one if you didn't get that. Let's get right on to the next part of this chapter, which is about custom transformer types. So there's basically two different types of transformer, custom transformer that is. One of them is embedded, and they're the ones I've been using so far, and the other one is called linked. And the embedded transformer is one that's definition falls inside the workspace itself. So here, for example, we've got this density evaluator. Its definition is in that tab. So basically, this custom transformer is available inside of this workspace and inside of this workspace only. It's stored, its definition is stored inside this workspace. It's only available inside this workspace. However, the custom transformer can be linked instead. Let me find my instructor workspace. Linked custom transformers. Let's have a look at this. So I've got a label creator transformer here, and it just creates a label out of this. It's not really a huge transformer. It's not really a realistic one. You wouldn't do something like this because it's only got one transformer in, but we'll say that's what it is for now. So what I can do, are we talking about this in the manual yet? Okay, so maybe I should just mention some of the advantages and disadvantages, because the linked custom transformer is a definition that's stored outside the workspace as a separate file. I don't know if we've got any on that machine, but if I just pull up a file browser from my own machine, I'll look in Documents, FME Transformers. If I look in this folder, we can see there's a whole bunch of these FMX files in here. And an FMX file is basically a custom transformer definition that's been exported to a file. And so when it's exported to a file, that means I can use it in any different workspace. I can give it to somebody else to use in one of their workspaces, and so on. And so when you use a custom transformer in your workspace and you link it to that definition file, then it's called a linked transformer. And there's advantages and disadvantages. The advantages of embedded transformers, like this one, the green one that's embedded, is its definitions inside here. It's in the same workspace. There's no external file I've got to manage. The definition's embedded in here. It tidies my workspace nicely. But it's not really a good way to share and reuse that content. I can reuse it in this workspace, but I can't reuse it in a different workspace. Linked transformers, well, okay, they're a bit harder to manage because they exist in a separate file. And that's a bit less convenient, especially if, say, you were pushing it to FME server, you'd need to send that FMX file as well. However, it's easier to share among other people. I can send that file to other people, and we can also point to the same definition of that. So I could say, point my workspace to an FMX file, and you could point your workspace to the same FMX file, and we'd all be using the same transformer definition. And that way, if somebody edited that definition, we'd all get the benefits of those changes automatically. Let's have a look. How do I create this linked and exported custom transformer? Well, let me go into my definition of this label creator. Again, I said it's not really a realistic one, but we'll do it anyway. So what I do is I go into my definition, I click File, Export as Custom Transformer, which is a bit odd because it's already a custom transformer, but there we go. So Export as Custom Transformer. And it opens up this dialog and says, okay, well, just to make sure, what do you want to call it? What category do you want it? And where do you want to save it to? And normally you save it to your documents FME/transformers. As we'll see in a moment, we can change that to be something different. The really key one there is insert mode. So if I export this, what I'm doing is I'm creating this FMX file, this custom transformer definition file, and I can use that within my workspace as I like. Now we've got two choices there. I could say point from my workspace to that FMX file definition, or I could say I'd like to use this transformer, but I'd like to take the definition and embed it into my workspace, please. And we have the option here to say how this transformer is going to be used when we export it. We can say that anyone who uses it is always going to link to that transformer. It's always going to be linked. Or we can say this transformer is always going to be embedded. So if I say, place me a label creator, it'll say, okay, and embed it into my current workspace. It won't let me link to that external file. And the other options we have are to do either of those, but to just make that by default, which means that we can switch from one to the other. And you'll see what I mean shortly when we do this. So what I'm going to do here is I'm going to choose linked by default for this custom transformer. And we'll talk about what that means in a moment and why I would do that. So I'm using linked by default for that custom transformer. So what happens is FME says, okay, let me take that definition, I'll wrap it up into an FMX file, and I'll export it to that file. So now you can see it's opened up a new instance of Workbench, and the heading at the top is label creator, and the file name is documents FME transformers label creator.fmx. In fact, I can even browse to that folder and find that FMX file there. So that's my custom transformer definition now. It's in that file. I can open that up and I can make edits however I like in Workbench, then save the changes to it. So really, it's the same sort of thing as a custom transformer that we've done before, except the definition is held in a separate file, and I just have to open that separate file up to edit it. So that's what we've done. Now, how about where it gets used? And that's interesting. So if I go back to the workspace where it was being used before, it says, okay, well, you've got a cyan color custom transformer now. Why is it cyan? Well, that's because it's not embedded anymore. It's linked to that definition. So if I make any changes to that definition in here, and save this, when I run this this workspace, it will be affected by the changes that I've made because it's pointing to that transformer definition. So my label creator transformer in here is linked to this file here. In fact, if I hover over it, it might even tell me that it's linked to it. It says it's linked. It doesn't tell me where it's linked to. I think there might even be an option to turn that on. So if I look under FME options, maybe under transformers, transformer options, I was pretty sure display transformer version, display link transformer file name, there we go. So I can turn that on, and now when I hover over this, it doesn't just tell me that that's linked, it tells me what the file is it's linked to. So it says, okay, this is linked to FME/transformers/label creator.fmx. So now we've got an exported definition. And somebody was asking earlier, like, how do I point one to like create all these custom transformers and point different workspaces to them? This is how you do it. So again, I can place another label creator in here. It comes up in Quick Add, and I place that. And again, if I hover over it, it should say linked to that file. And if I fire up a new instance of FME Workbench, like fire up a completely new workbench, different project, I can say, oh, let's put one of those label creators down. They're great. So here we are. Oh, look, it's listed under custom transformers. Place a label creator, hover over it, that's linked to the same file. So this is how I can have one custom transformer definition, but all of these different workspaces are pointing to that same file. So if I make the change there, it will change in the workspace. Now the disadvantage of that is if I say, oh, let me send this workspace to somebody else, I have to send them that FMX file with it. Otherwise it won't make any sense. It won't work for them unless they can point to the same folder, which you could do if it was a shared folder, I guess. So yeah, lots of workspaces can point to that same transformer. But remember, when I saved that custom transformer, I saved it or exported it with this option that says linked by default. What does that mean? Actually, let me just check to make sure I'm on the right content on this page. Okay, so I'm just going to go back and before I mention that, I'm going to mention what are the advantages and disadvantages of using it embedded or linked. Well, linked is a good choice when I intend to share that transformer with other people, because I can take that FMX file and I could say, let me email that to, well, that's not the right folder. What I can do is I can go to that definition, right click on the main tab and say open containing folder, and that'll show me where it is. Anyway, I can take that FMX file, I can copy it, I could email it to somebody, send it to my documents folder, whatever, and you could use that transformer, double click it, it would install that transformer, then you could use it on your computer. So it's better for sharing. Yeah, the embedded version, that's better sometimes because you can give it with the workspace, but it's also good for, let me see, let me just, I'm going to go on to the next page because I think this really comes under the next part, which is how do I switch custom transformer type? So we'll talk about this, and do you really want to let people switch the type? So here we've got the definition is the FMX file. This transformer points to it. But what I can do is I can right click on that and say embed. So I right click embed, and now look, it's turned green again, and the definition is embedded inside my workspace again. Now it's no longer related to that FMX file. If I make changes to this FMX file and save it, this workspace won't make use of it because this workspace is now using an embedded definition. So I can flip backwards and forwards. I can say, let me link to that. So now I'm linked again. Or let me right click and embed. And now I'm embedded again. And if I'm embedded and I can choose edit, I can make the edits to this. So now I can make changes to my embedded definition. Like I could go back into there and say, actually, I want to change the height to be a fixed value of 15. Now that's my embedded definition. It's not the linked version. The linked version is different. So you can start to end up with different definitions in different places if you're not careful. But usually you only end up with one or two. You end up with the exported version in the FMX file, and somebody might embed it in their own workspace instead. So when is this good? When is this bad? Why would you want to stop people switching? Well, quite often I'd want to stop people switching if I wanted to stick with a standard. So if I had a workspace, a custom transformer that produced the standard data, I would probably export it as an FMX file and make it linked only so that when somebody placed it in their workspace, they could not set it to embedded. That way I know that they're using my central definition. They can't edit it, they can't change it, they're going to get the standard data out that I want them to get out. If it was more of a template, like the density evaluator, it's like, well, it's my density evaluator, but I guess it doesn't matter if you make some edits to it and do some improvements if you really want. So then I would make it so that you could embed it when you use it and make your own changes to it. So that's when you use the linked versus embedded mode, and whether you give the end user the choice of switching between them as well. Notice now that I can't switch back to linked in this. Why can't I switch back to linked? Because I've started to make changes to it, and this definition in the embedded form is no longer the same as the definition in that file. And if that's the case, FME won't let me switch backwards and forwards between embedded and linked. If I want to go back to the linked version, I would have to delete that transformer. It says, oh, you're about to remove the last instance of that. Do you want to delete the embedded definition? And I say, yeah, actually I do, because I want it to be linked again. So now I just go back to linked and there it is, it's linked again now, and I just need to pick whatever my parameters are here, like so. And now once it is linked, I can go back to embed, linked, whatever I want. But while it's linked, it's pointing to that FMX file, it's using that definition. If I switch it to embedded and make some edits, now it's no longer pointing at that, it's using my own definition in here. So that is how we can switch your custom transformer types. And again, you might not want your users to do that. You might create this custom transformer and you don't want people to switch. You just want them to use it in the linked mode or just embedded mode. You would perhaps say just embedded mode if you wanted to supply them, share them the definition, but you didn't really want them to point to it. So let's go back to that FMX file. I think we might be able to change. Let me check if we can change that so it always. I don't think we can. I don't think we can set the embedded or linked by default thing in here. Once it's been chosen, I think it's been chosen. Oh no, there we go. Transformer insert mode. I can double click that and I can save that to be something different. So now if I say it's always linked, if somebody, actually I'd have to save that definition and we would have to be aware about it, which I just need to refresh the transformer gallery. But now it's linked by default and it's only allowed to be linked. I'm not allowed to switch. So if I place this label create a transformer, I shouldn't be allowed to switch now. I right click, I can't embed it. It's fixed at being linked because the custom transformer definition says linked always. So yeah, so like somebody mentioned in the questions, linking works well for a team of developers. And the other reason it works well for a team of developers is because of this nice bit of functionality, which I'm going to talk about now. If we look at Tools, FME Options, so click Tools, FME Options in Workbench, and one of the options down here is Default Paths. And the default paths includes a shared folder name. So what I could do is I could open up my just sort of file browser, go to my PC, C drive. I'm going to create a new folder. I'm going to call it FME Share. And basically I'm going to right click on that and I'm going to use the share option, share with, and maybe I'll share it with everyone on this training course, for example, or whatever. I can choose who to share it with. So I click the share button and that file gets shared. So now, and it will probably get shared like as a drive number or machine name or something like that. So now what I can do is come into my FME and say, let's find that shared folder. And I'm going to use that as a share within my FME. And I just click OK on that. And now that is one of my shared folders. So what does that mean? It means if I've got a transformer, an FMX file that's inside here, FME will automatically pick that transformer up. So now everyone in my organization, I could say to you, go to Tools, go to Options, hit the plus button, go to // my machine / FME share, add that as a shared folder, and then all of the transformers I've created, they'll now appear in your quick add. And then, so we've now got a sort of central repository of shared custom transformers. So this is one way we can share in an organization a custom transformer definition between lots of different people. And you'll also notice it lets you do other things as well, like coordinate systems. So if I build my own coordinate system and put it in a shared folder, and your FME is connected to that shared folder, you would see my coordinate system available on your FME as well. So shared folders like that are fantastic for organizations and working in a group as well. So yeah, so that's how that works. Let's have a look quickly at versioning. So how do we version a transformer? Why do we want to version it? Well, basically FME lets you version a different transformer, so you can create several definitions of your transformer and give each one a different version, and people could say, oh, I want to use version 1, or no, I'll upgrade to version 2, and so on. So how do we do that? Well, let's go back to my definition of my custom transformer. Let's say I start making some changes in here. I keep hitting the save button, make some more changes, hit the save button. It's not asking me about versioning. It's sort of like having an edit session, if you like. Currently, I'm in the same edit session, so even if I do make some more changes and save, I'm still saving as version 1. It's like it's unversioned right now. What I need to do is to close the custom transformer down and then just open it back up again. Now, if I start to make some changes, say I add a rejected port. So I'm going to add a rejected port to my transformer. And I connect it up like that. Now when I hit the save button, because I closed it down and opened it up again, it says, oh, you're about to save this custom transformer. You've got a choice. You can overwrite the existing version that's there, or we can create an entirely new version of this transformer. And in this case, I'm going to say, let's create a new version. And you can see now at the top on the menu bar, it says label creator .fmx version number 2. Whoops. So version number 2. So that's my custom transformer now, version 2. So we've got that. Now, next time if I close that down and open it up again, it's going to say, okay, well, you're opening this transformer. It's even going to ask me now when I open it, it's going to say, well, you got the choice. Do you want to keep editing version 2, or do you want to move up to version 3 now? And I'm just going to say, let's keep on version 2. That's good. Make some more changes, hit the save button, and we're done. So how does the user find that version 2? Because currently, if I hover over that, it actually says on the tooltip version 1. So how do we get it to upgrade to version 2? Like if I right click, it doesn't say upgrade. So how do we do that? Well, we just FME needs to know that that new version exists. And the best way of doing that, well, normally it will do that if you shut Workbench down and open it up again. So next time you start Workbench up, you say, oh, look, there's version 2 of that transformer. But if I know there's a new version or I want to check manually, what I can do is go into this transformer gallery window, which again, if you don't have open, view Windows, transformer gallery, and in the bottom right of that is a little sort of reload button. I can hit the reload button and it'll go away and it'll look for new custom transformers on the hub or locally. And now it's got the proper list. So now if I right click on the label creator, oh, look, it says upgrade to the latest version. So I can hit the upgrade button. Oh, it upgraded. I've got a rejected port now. Fantastic. And if I hover over it, it should say you're now at version 2 as well. So basically, the author can make changes to this. They can choose whether to create a new version or just to stick to the old version. And as an end user, I can do an upgrade to a new version or not, depending on what I feel like. So when might you choose to create a new version and when might you not? Well, so I'd probably do the existing version if I was just changing something inside the definition itself. Like say I was putting an attribute filter down or a geometry filter. Say I'm doing something inside the workspace that the user doesn't need to know about. Like I'm just going to filter out points because I want to replace points and areas, because they're the only ones I want to replace with a label. So we're going to keep those, and everything else is going to be rejected because you can't add a label to a raster, for example. So that's an example of where I wouldn't even bother to create a new version. Why? Because there's nothing for the user to see. There's no like new port on the input or output. It's just a different in the functionality inside of it. So I'm not even going to bother creating a new version. And because it's not a new version, if I run this transformer, it'll just run and use that contents and it'll be happy. The only time I would create a new version is if I was doing something that would affect the user. So for example, I'm going to create a new version here because what I'm going to do is add a user parameter that says enter your name. Enter your name. So this is something the user is going to have to interact with. So that's why I'm making it a new version. So the user can't get confused by something, or they'll have to upgrade to get this new functionality. It's not going to be something that's there, but something they can't really use. So I've just said enter your name. That was version 3. Again, if I was the user, next time I start Workbench up or hit the refresh button on there, I could right click and say, oh yeah, look, it's got an upgrade. I'll upgrade. It's got version 3. Oh, it's got a new parameter for entering my name into. So like that. Now the other reason for versioning is related to your version of FME. So say I create a custom transformer, well, like I've just done, I've created this custom transformer and it was created in FME 2019 and that's version 3. Say I come back next year and I open up this definition and I add a new piece of functionality like a new transformer inside that only exists in FME 2020. What happens to that transformer now? Well, it means that this user who's still using FME 2019 could not use my custom transformer because it's got this new transformer inside its definition that isn't compatible with my older FME version. So that's another case where I would add a new version to this custom transformer. I would open this up in 2020, in FME 2020. I would create a new version. I would put the new transformer down, whatever it is, that's new to FME 2020, and I would save that. And the user who's using still 2019, they'd refresh their workspace and they'd right click on the transformer and it wouldn't say to them, there's an upgrade, because that upgrade would have been made in 2020. They're only using 2019. So you would often create a different version for each different version of FME, and that way it makes everyone's workspace backwards compatible. If you upgrade your custom transformer, it doesn't stop other people's workspace running because they'll just keep on using the old version that is compatible with 2019. And once they upgrade to 2020, they can right click and it's like, oh, there's a new version in 2020. Let's upgrade to that. And then it would be on version 4. So again, version of your custom transformer is tied as well to the version of FME that you've got. And so it's quite useful to be aware of that. Now there's a couple of questions and a question in the manual as well. The manual said you've got a linked custom transformer that's version 1. The author makes a series of edits. They upgrade it to version 2, then 3, then 4. So what happens to the user who comes along and says, I'd like to upgrade, please? Well, the answer to this, I think, is it depends on what version you're using. But if you were using the same version, it would upgrade to version 4. So in other words, if I go to my definition file and make some changes, open it up, create a new version, make some more changes, save that, open it up, make some more changes, new version, sorry, make some more changes, save that. So now I'm on version 6. This user, I can see by hovering over it, is still on version 3. What happens when they upgrade? Well, what will happen, it will upgrade it directly to version 6. It always upgrades to the latest version that's available. So it should now say version 6. I can't upgrade my transformer that's pointing to that definition to one version at a time. The other thing I can't do is I can't roll back my versions in here, which I think would be a useful piece of functionality. I can't say, oh, version 6, that was a mistake. Let's just like scrub version 6 and go back to version 5. I don't think I can do that. That would be a very nice piece of functionality to have. But I guess that would be a problem, because if I did say scrub version 6 and go back to 5, then what happens to a user who's using version 6? That will be a problem. So I think you can only move forward. If you said, oh, I didn't want that bit in there, I want to go back to version 5, you would just say, well, let's make version 7 the same as version 5. But yeah, rollback would be quite nice, but yeah, it just doesn't happen right now. So, but you can look on our website and suggest that as an idea, and that would be great, because it would be quite a useful bit of functionality. Okay, so let's go back to doing an exercise so you can do some hands-on. This is a new exercise. It's not following on from before, so let's just make a start on this. And basically, it's going to be covering linked transformers and versions, the same as I've just been demonstrating. So we start out with being a bit cynical there. Say we arrive early at the office for a meeting, but it's cancelled at the last minute. Still, it gives us time to carry out an FME project that's been on our mind that we just haven't had time to do before. A transformer to calculate the average length of linear features. So quite a few times before, I think I've added an average area calculator transformer, and I put it on the FME hub. So you can see that one's been downloaded 560 times, and you can see why it's useful to have that information again in the transformer. But I added an average area calculator. The person in this exercise here has thought, well, why don't we have an average length calculator as well? So that's what we're going to do here. Okay, so let's open up the starting workspace. FME 2019, Workspaces, Desktop Advanced, Custom Transformers, Exercise 4, begin. So we're going to create, I mean, they're basically calculating, not even calculating the average length yet. We're going to have to do that. But we're going to calculate it and use it as a custom transformer. So put a length calculator transformer down, connected to that line combiner, put a statistics calculator down, and we're not even going to worry about the settings right now, because I'm not too worried. We can edit those in a bit. First thing we'll do is create a custom transformer. So select those two parameters and press Control T, and we'll create a new custom transformer, and we'll call it the average length calculator, like so. And we'll category, could be training or calculated values or whatever you like so. And we can put a little bit of a description in there. It's not really that important. A transformer to calculate the average length of linear features. My typing seems to be better the faster I go. I don't know why, but if I type slowly, I'm less accurate. Okay, so we do that. We give it a name, we give it a category, we give it a description, we click OK, and here we go. We've got that. We are going to rename the input port to lines, because I mean, lines are what should be coming in. If we're measuring the length of something, it's got to be a line. It can't be a point. So we're going to say that's line features and prompt the person, should be lines, not line. Oops. So we're going to prompt the person what they should be adding to their custom transformer. We got the length calculator, the statistics calculator. Let's open the parameters for that. And oops, not group by. Attributes to analyze. Let's click on that and choose the length attribute. So we are saying measure the length, then analyze it and calculate. Let's see. Well, it's calculating everything, so that's fine. Let's just click OK. So it's calculating all of these different values like so. Now I don't have an output port, so I'm going to right click and choose Insert Transformer Output to give myself a new output port. I'm going to connect it to here, like so. Now let's have a look at the settings for the output port that I've got. Currently, it's outputting every different attribute. So all of the attributes that I've got in here are being output. And I don't really want that. I could just not calculate them in the stats calculator, but what I can do is I can just say, do specified attributes only, and it's the mean, although it shouldn't be the mean. I'm going to rename that now. It should be, instead of mean, it should be average length, like so. Yeah, I thought it might complain. It says, oh, we don't have mean anymore. Okay, we won't do that. We'll just pick average length. So I'm just specifying one attribute to be output here. Now, if I go back into the main tab, I can see that it's only adding attribute length to my output. Notice that even though I said only output average length, it's also outputting all of the existing attributes. It's not going to dump all of the existing attributes. It's only going to get rid of anything that was created inside the custom transformer. So I'm only adding one attribute to the output, but it is adding it. It's not going to delete anything that's coming through there already. Yeah, let's run that and do visual preview. I'm not going to have, I don't have caching turned on, so I'm just going to add in the inspector transformer, and I can see in here that we have these paths, and if I query one of them, we should have, excuse me, the average length. The average length is 600 meters. Okay. Now let's experiment using different transformer modes. So go back to the average length calculator definition, click File, Export. In fact, I think I can even right click where it says on the tab itself and say Export as Custom Transformer. That's another way of doing it. So either use File, Export, or right click and Export as Custom Transformer. Average length calculator, calculated values, and we are going to set it to insert mode, linked by default. Interesting, let's look at the save location. You should have only one save location, your documents folder. Interesting. I thought I set up, oh, okay, I set up a shared folder, but because I haven't restarted Workbench, it doesn't, this instance of Workbench didn't know that I created that other instance of Workbench. So I'm just going to see if that works. So this was exercise 4, begin. I'm going to shut down Workbench and start it up. You don't need to do this. I just want to see, I'm doing a bit of off-roading again, a bit like Ryan was doing yesterday. We don't need that either. So if I open that back up again, come into here and do export, I'm hoping it should let me export it to, no, I thought it would let me save it to the shared folder that I set up before. I'm pretty sure I do have it set up as a shared folder still. Oh, it disappeared. Okay, well, I don't know why that is, but FME share, that's my shared folder. Click OK, export this custom transformer. and I can save it to that shared folder instead of my basic default one. So again, you wouldn't need to worry about this. I just wanted to do that to show and to prove that it does work. So I'm exporting it as a custom transformer. Did I say linked by default? I can't remember. No, I had embedded always. It should have been linked by default, but that's okay. I can change that. Actually, that does make a bit of a difference because in my original workspace, if I said linked by default, it would have shut down the definition and made it linked by default. Whereas here, it's not done that. So let me right clear. It should let me link that. See, if you did linked by default, this wouldn't have happened. It was just me rushing through it. That is very... Oh, I wonder if this doesn't have the same... No, it does. It has that. See, I'm making a total mess of this from... No. Okay, so what I'm going to do is I'm going to shut that back down and start it up again. And I'm going to delete that FMX file so I don't have to worry about it. Okay, let me try that again. Back in the average length calculator, export that. Weird, but average length calculator. It is calculated values, linked by default, no password, and I'm going to put it on my usual folder. That's what I get for going off-road, I guess. And there we go. So now it worked. So if I go back to my main workspace, it actually closed that tab down and linked me automatically because it knew I would be linked by default. So that's what you should have got. So you should be in this position now where you've got a transformer that's linked by default, and it's now a blue cyan color because of that. And you can right click on that and choose embed. You can right click and choose link because we said by default. If we'd have said just link only, I wouldn't be able to do this. I wouldn't be able to switch backwards and forwards. So yeah, if I embed and then I edit it, I make some changes, come back to the main canvas, I shouldn't be able to link it again because the two definitions are now considered different. Okay, so delete that. When it prompts, delete the definition. And as it says, it's important to remember that the definition for an embedded transformer is in the workspace. So if I deleted the last instance of that embedded transformer and said, no, don't delete the definition would still be in there, even though I've got no instances of it. Anyway, let me put that back in. What was it? Average length calculator. There we go. So there it is, back in there. And if I hit the browse button, because I've already done step 8 and set those different parameters, settings or options, it's telling me it's version 1 and it's linked to the average length calculator.fmx file. Okay. I think I'm down to here. Return to the instance of Workbench where the FMX file is open. Okay. Let me do that. There it is. Move one of the objects about to activate the save button. Click the save. Notice that you aren't prompted to save a new version. That's because versioning has not been applied yet. So we're still sort of in the same edit session. We're still unversioned or something like that, depending on how you want to think of it. So leaving Workbench open, close that FMX file. I normally do that by just clicking the cross on the main tab. I guess you could hit File, Close, but I just hit the cross on the main tab and it just closes it down. Open it up again. And there it is. So we're still not in sort of versioned mode yet. So it didn't ask us if we wanted to create a new version, but it will do when we save it next time. Okay, so step 9. So we've created this custom transformer, we've exported it, we played about with embed and edit and link just to see what would happen. Now let's version it. Rather than just jiggling transformers about, let's actually do something useful and put a geometry filter transformer in, like so. So a geometry filter transformer, this is going to filter out geometries that we can't possibly measure the length of. So I'm going to click on the parameters and say I only want lines and arcs. Actually, area features would be okay as well, because if you measure the length of an area feature, it gives you the perimeter. But let's not worry about that. We're just going to go with lines and arcs. Okay, so we just got to do a bit of schema mapping there, because lines and arcs are the bit we want, not the unfiltered. So let's connect those up. And we have the unfiltered, and we're going to do what I did before, is I'm going to right click, transformer output, and put a rejected port in there, like so, and connect that to the unfiltered data. So I put a geometry filter transformer down, opened up the settings, chose lines and arcs as the ones geometry that we do actually want to keep, and connected them up to the length calculator. And the unfiltered output, I just sent that to a new output port, which I just did right click, insert output. I called it rejected, connected that up. Now that data will be rejected. Now, if I want to be a bit more complete about this, what I could do is I could put an attribute creator transformer down here. And this, again, I'm sort of off-roading, but I could put an attribute creator down and say, let's create an attribute called underscore rejected underscore reason, and we'll give it the value invalid geometry for length measurement, like so. So if I'm going to send features out through a rejected port, I can give them a reason for that. And you've got to think of it in terms of, well, any other transformer in FME, like the statistics calculator, length calculator, things like that, they often, if they reject features, give you a reason why it's rejected. So if we're creating our own transformer that people are going to be using and sharing, we should do the same, really. We should sort of hold that same high standard. So that's why I'm just creating this attribute here that says rejected reason invalid geometry for length measurement, so that when someone uses my custom transformer and a feature gets rejected, they'll at least know why it's been rejected. So I just did that as a bit of an addition there. And you could do anything you like. I mean, you could put a terminator transformer down that stopped the translation if it was bad, but I wouldn't normally do that. Okay, so I hit the save button. It says, okay, you're saving this transformer. It's a new edit session. So do you perhaps want to create a new version of this? And I'm going to say yes, especially because I've got that new rejected port. That's the big change that the user needs to know about. So I'm going to hit yes, new version. Now, if you hit save and you didn't get prompted for that, it's because you didn't close your workspace down and reopen it. So if that's the case, close your workspace, reopen it, jiggle something around, hit save, and you'll get that prompt. Okay, so we made that change. Let's go back to the workspace that's using that transformer. If I right click on it, it doesn't say upgrade to latest version because it doesn't know that version exists right now. If I shut Workbench down and restarted it, maybe even if I shut the workspace down and open it up again, even then it might know. No, it didn't check. I'd have to shut Workbench down and open it for it to know. But like I said before, the other way to force it to check is to hit this reload button on the transformer gallery, and that will go away and it'll say, show me all of the new transformer versions. And now we can right click and upgrade to the latest version, and it gives a rejected port like so. And it's even got a rejected reason attribute, so we're all good. And like it says there, you could do as I did earlier, put it in a shared folder, have other users share it. I don't necessarily need to do that. I could email it to somebody else. So for example, say I've got, let me find one of my transformers. Okay, I've got a custom transformer on my own machine that I'm going to copy into here. So if I just go to Documents folder and paste it into there. So say somebody sent me a custom transformer, it was called testct1.fmx. How would I deal with that on my computer? Well, I would just double click it and it will say installing that. Do you want to install it? Yes, I do. Successfully installed. So the file's still there in the Documents folder, but I'm going to delete that because it's actually been installed under the usual folder, which should be FME Transformers, and there it is. So basically, it's installed it, and because it's installed it, the next time I go into FME, I should be able to test CT1. There it is. So I can place it. So if you send this to somebody else or they send you an FMX file or something like that, all you need to do is double click it, FME will install it into the right place, and from that point on you can just use it on your computer. And of course you'll be pointing to your definition, you won't be pointing to their definition, but again, that's up to you how you organize your setup. You can have one central definitions that everyone points to, or you can share it about and just install it on your local machine and use it there. Question there about can we use a custom transformer in a TFS or Git repository? Not yet. That's really high up on the list of things that we want to do. If we look on our knowledge base and we have an ideas thing on there, the very top idea, the most votes, is Workbench connects directly to revision control. So that is a big deal. So we have 108 people want that functionality. So we are going to do that, especially via Git by the look of it. So yeah, that's going to happen. I think that's got to happen. It's just so requested that we're going to have to do that. Now, having said that, FME Server does already have integration of some sort. I'm just not sure how it works because I've never used it, but FME Server does have that capability. Okay, so we got about 40 minutes left. Does anyone want to take a break now, or shall we just keep pushing on until the end to get finished earlier? I don't really mind either way. If you want to put a comment about whether you want to continue or take a break. Okay, so yeah, everyone so far says keep going. So let's keep going because we've only got a couple of little bits to do, and I know what it's like. It's late over in Europe, and so, or wherever you are in the world. And if you're in Australia, it's so late it's already tomorrow. So let's just keep going. Okay, so we'll go through these fairly quickly. We'll do parallel processing. We might skip loops because they're very rare that you use them, and they get complicated quickly, but for now we'll definitely do parallel processing. So what is parallel processing? Well, parallel processing is a way to improve performance on high-end machines. Basically, your machine, if it's like mine, will have multiple CPUs, multiple cores on it, and you want to make use of those cores. And FME, if you run an FME workspace, you will see that FME is, oops, let me just shut a few of these windows down because I don't need them all. But if you run a workspace in FME and you look at the task manager, you will see one instance of FME.exe running wherever it is. Processes. Okay, it won't be here now because I'm not running FME, but somewhere once I hit the run button, I would get FME.exe running. And I've got two FME.exes already running because I've got server running on this computer as well. So that's why I've already got two processes there. But basically, whenever I run a workspace in Workbench, it's a single process. Now, that's not very efficient. There must be better ways of doing things. And yes, you can set your workspace up to parallel process things. Now, how you do that, you do it inside a custom transformer. So let me show how that works. Constructor use, and we are on parallel processing. Okay, so I've got my addresses. I'm reading my addresses. I've got an attribute manager doing some stuff, renaming things. So I've got a whole bunch of like 15,000 address points. I've got address ID, postal address, and postal code. And I'm putting it through this label creator transformer, which just creates a label. Simple as that. And I get to say the postal address is the label and a height of 5. And I can hit the run button on that. And again, if I look on my thing, here we go. We've got one FME.exe process running, and it ran like that and it finished. So that's fine, but couldn't we do things in parallel? Is there a way we can parallel process that? Well, yes, there is, because it would make sense if we could split the data up into groups and say, well, let's create 4 different groups and each group gets its own process and then they should run 4 times quicker, right? So that would make sense. So how do we do that? Well, we do that in a custom transformer. So if we look in the custom transformer definition, in the navigator window under advanced, is it under advanced? Oh no, there it is, just under parameters, parallel processing. So right now there's no parallelism going on. We're not doing any parallel processing. If I double click that, we get a drop down list and we get to choose how much we want to really push this. Do we want to just do a little bit minimal processing in parallel? Do moderate? Do we want to get aggressive with it? Or do we really want to like push this to the extreme and have as many processes going as we can? So we get that choice. Now, what does that choice mean though? Like, how does it relate to numbers? Well, it relates to numbers using these tables that I've got here in the manual. So, and it relates to the number of cores on your computer. So I don't know how many CPUs I've got on here. Like I've got one CPU, maybe it's got 3 or 4 cores on it. So I'm going to assume it's a quad core processor, 1 CPU, 4 cores. So if I say do moderate processing, if I do moderate processing, it creates the same number of processes as I've got cores. So if I've got a quad core machine, it'll give me 4 processes. If I say go to extreme and I've got a quad core machine, it'll do 8 processes. Usually you want the same number of processes as you have cores, because if you have more processes going on and you've got cores, then each core is like doing a bit and then it said, oh, I got to swap and do this other process. So you're sort of overloading the cores with 2 processes each in that case. So normally you would do the same number of processes as cores, but you can go extreme if you like. You can go minimal and say, hey, just give me 2 processes, and then 2 of the other cores might be doing some different stuff if I've got like a database I'm querying or whatever, and so on. It also relates to the number to your FME license as well. So if you've got a professional license on a quad core machine, you could get a maximum of 8 processes. If you had a base edition license, you'd only be allowed 4 processes at once. So basically the amount of processes you can do at any one time depends on what setting you choose here, the number of cores you have on the machine, and what FME license you're running. And all of those combine. And in this case, if I've got a quad core machine, I'm going aggressive with a professional license, I'll get 6 processors. It gives me up to 8. I'm only going to be doing 6. If I go extreme, then I'd hit that maximum of 8. If I had 8 cores on my machine and I went aggressive, well, that would normally give me, no, sorry, if I go extreme and I've got 8 cores on my machine, normally that would give me 16 processors. But if I've only got a professional edition, I'm only allowed a maximum of 8. So I'll only have 8 processors going. But if I was on any like a database edition or a small world or something, then I could get the full 16. So there's that combination of what you choose, how many CPUs you've got, and what license you're using. And that's the maximum number of processors at any one time. So if I go into here and say, let's do some extreme processing, great, I'm going to get, probably going to get 8 processors if this is a quad core machine. Now the thing is, I said what you would need to do is split the data up by group and process each of those groups on a different process. How do I choose the groups? Well, when you say you want to do parallel processing and set that extreme or whatever level, FME automatically published a parameter for us called group by. So what I'm going to do is click group by. I'm going to select the attributes and I'm going to group by postal code. So in other words, take all of the addresses in one postal code and process them in a separate group. All of the addresses in the other postal code, put them in another group. And so if I hit the run button now and look at my process list, I should get, here we go, we're firing up all these different processes now. So we've got 1, 2, 3, 4, 5, 6 processes going, or is it just 4? I can't really count there. There's the 2 being used for server as well, of course. And we get this FME objects worker as well. Some of those are related. So we're firing off new processes. Look at the log window. It says transporter sender, transporter receiver. It says I'm sending data to another process from this process, and so on until it gets down to the bottom. And it's still going. There we go. So this illustrates, I think, the dangers of doing parallel processing. The danger here is that the workspace was so fast it ran in about 3 seconds anyway. Now I'm doing parallel processing, I'm getting the same results, but it's taking so much longer. Why is that? Well, there's a cost. There's a cost involved in starting and stopping each process, and there's a cost involved in sending data to and from each process. And here, I'm not even sure how many postal codes I've got. There's probably several hundred, if not thousands, in the city, because it's going down to the street level, really. So it's creating so many hundreds of different processes, and it's only doing a maximum of 8 at any one point. So I'm creating like 1,000 processes, but it's only doing 8 at a time, because that's my maximum is 8. It's not going to give me a process per group. It's only going to do that to a maximum. But anyway, it's starting that process, it's stopping that process, it's sending data backwards and forwards, and it's slowing it down. So if that's not good, then when should you use parallel processing? Well, it's effective in 2 scenarios. The first scenario is a small number of groups with a large amount of processing to do. So if I was doing, say, dissolving a bunch of polygons, I got like 1 million polygons, I'm trying to dissolve them in different groups. If I could say, I've got 4 groups, I'd like to dissolve them separately. So each of the 4 groups is doing a huge amount of processing. That'll be a good candidate for parallel processing. What's not a good candidate is what I'm doing here, where I've got 1,000 groups and each group is just doing like something very quickly like that, really quickly. And it's taking longer to start and stop that process and send the data backwards and forwards than it actually is to process it. So a lot of small jobs going on is not really the best way of doing things. You want to have a small number of large jobs rather than a large number of small jobs. And that's what we're illustrating here. Now, having said that, you can get away with a large number of small jobs if you're passing features to a web service. You can just sort of fire jobs off like really quickly, and the web service might stack them all up, and I guess they might even think it's a denial of service if you do that many. But that would be one example where you might want to be able to do lots and lots of small jobs. So that's just a warning there. I'm going to stop that because we've only got 330 features output. This is getting ridiculous. Somebody asked, by the way, how I get that extra node in my workspace. That's just a junction transformer. The junction transformer is just like an input and an output, and it does nothing. It's a transformer like any other, but it doesn't have any settings. All it is for sort of putting on the canvas to tidy your workspace in various scenarios, or connect it like this, just so I can see the counter features going through. It doesn't really do much. What I might do in this actually is, let's put caching on just very quickly. I'm just going to run that, and actually I know what I can do. I can put an attribute filter down. I want to find out how many, actually, duplicate filter. I want to find out how many unique postcodes there are, because that was really causing me a problem there. So I'm going to go by postal code. How many unique postal codes were there? Okay, there were 2,904 unique postal codes. So it was stopping and starting nearly 3,000 processes. That was not a very good example of what we should be doing. If I did have a good example, I'd show it. We were here all day, because it would be, because it really only is worth it when you're doing heavy processing. The other thing we could do is we could create artificial groups, like as long as the data is not related to each other, because each parallel process is standalone. It's not processing things together. If I had something in here that was like a neighbor finder, and I said, find me the nearest something to my each address, and ran that in parallel, well, then I might have problems, because if it's splitting my data up into different groups, the nearest, like say firehole, if I was looking for the nearest firehole to each address, well, the nearest firehole might be in a different group, and I might not see it from my other group. So you have to make sure that all of the data that you want processed together is available within that same group. And if it's not, then things are gonna not work. So each group is standalone. It's not working by it's not interacting with each other. It won't say, take this group of addresses, find the nearest firehole, which is in a different group. It won't do that. So you've got to be aware of that. In this case, it didn't really matter, because the addresses are all separate anyway, and I'm just creating labels from them. So none of them are related to each other, so it's not an issue. So what I could do in here, I could say, hang on a minute, it doesn't really matter what my groups are here. And postal code was obviously a bad choice. Why don't I just split it up into 4 random groups? Can I do that? Well, yes, I can. There's a great transformer called the modulo counter. And the modulo counter counts, like the counter, it counts and gives an ID to each feature, but it resets after every certain number. So for example, if I say the maximum is 4, then it'll count 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And each address will get a number from 1, 2, 3, or 4. And that makes it perfect for use as my group in parallel processing. So I'm going to say, don't group by postal code, group by this modulo count, and let's run that again. We're going to turn off feature caching, because I don't think it runs too well with parallel processing anyway. Hit the run button. So now what are we going to do? We're only getting 4 different groups now, because I only counted up to 4, and hey, it finished just like that. So you can see it was still creating groups, it was still sending data from parallel processing, but it only created a maximum of 4 groups, because I said, hey, split my data into 4 groups. So the modulo counter and doing a group by, the result of that is a great way to cut down or specify exact number of groups. Again, you just got to recognize that if two features that should be interacting in this process are split into separate groups, then that's not going to give you the right results. Each group is being processed separately. It's not interacting with each other. In this case, it didn't matter. In other scenarios, it does. So yeah, so I created some artificial groups there and just parallel process my data. So let's do an exercise on that. We are going to create a custom transformer to parallel process data. So let's open up the workspace that is the beginning workspace for this, which should be Custom Transformers Exercise 5 Begin. So what have we got here? We are reading some OpenStreetMap data. We are reading some postal addresses, and we are getting the addresses from that. So what we're basically saying here is the city's investigating using OpenStreetMap data in their own spatial database and data portals. The big consideration is buildings. They want to load all the buildings from OpenStreetMap and put it into their corporate database, for want of a better word. But are those buildings correct? Are the building lists complete? We don't know that. They don't know that. So what they're going to do, or what they have done, is create a workspace to test. So they're reading the buildings from OpenStreetMap, they're reading their list of address points, and they're doing an overlay to say, does an address fall inside this building? And if it doesn't, so we've got a tester, and if it says no, there are no overlaps, then we put an error in there and say, hey, there's no matching address point for this building. That could be an error. So basically we're validating, I guess, the OpenStreetMap. We check if it's got an address. We validate the geometry with the geometry validator transformer. We check if it falls inside the right zone. So we find out what zone it falls inside using a spatial relator transformer. And if it falls outside the zoning, if it's an unzoned building, that gets another error. If it crosses over the zoning boundary, that's another error, because a building shouldn't do that. A building should be either residential or commercial or industrial. It shouldn't span across the boundary and be half residential, half industrial. So basically they're doing data validation and writing the output out to just a temporary file in this FME specific format. So that's what's going on in this workspace. They're reading some buildings. They're testing to see what the addresses are like. If address falls inside the building, it tests if the geometry is correct. It tests if the zoning is correct. That's what's happening there. And if we turn on caching and run this workspace, we'll be able to look at the results and see what's going on. So let's just look at that, what's happening there. And it's taking a little bit of a time. Maybe it will be quicker to parallel process. That's the thought behind it here. So if I browse across here, there we go. So 7,300 buildings from OpenStreetMap. And if we look at them, okay, that's an unzoned building. What am I looking at here? So let's see if I click an address or click up building, was it correct? Yeah, that one had no matching address, so no address point fell inside there. Neither did any of those. Oops, overlapping zones. So that building overlaps two different zones. So basically they're doing data validation and it works and it's fine. Could we parallel process this, make it faster? Well, let's let's try that out, shall we? One of the things we need to sort of think about is how can we parallel process this? We need to create groups. How are we going to create the groups? Will these buildings coming in all have a similar attribute? Like we look at this and it's like, oh, it's got a timestamp. We could sort by year and group by year and sort of process each building on a yearly basis, or we could do it by a username. But I mean, if you scroll down some of these attributes, you notice that they don't all have values. A lot of them are missing. So that means that it's not really, the OSM is not really a great data set for trying to create groups, because you're never going to know if any of the attributes are actually missing. So one of the things we could do is use the address records. And one of the things that the address records do is copies the address onto each building, including postal code. We saw before that might not be a great idea, but we can, why don't we take the first 3 characters of that postal code? That might be a bit quicker than before. So what we're going to do is select everything that comes after the point on area overlayer. So I'm going to select all of the transformers that come after that and see if we can make that parallel processing. I can't put my output in there because that won't work. Oh, that's not nice. Workbench crashed. Why was that? I don't know. Let's open that workspace up. Were there any changes in there? I'm going to say no, because I don't think I made any changes. I just ran it, so that's okay. Okay, so I'm selecting everything after that point on area overlayer up to that junction transformer that appears there. I press Control T and turn that into a custom transformer, which I just call a building validator or something like that. And click OK. So we've created our custom transformer. Okay, define the parallel processing groups. Yikes. So this is the custom transformer here. That's what we've got there. Let's just move these along so we can sort of zoom in a bit and see what's going on. There's my building validator. There's the zoning data coming into that. There we go. Yeah, so interesting. We had the reader feature type inside the custom transformer, but it doesn't actually get to stay in there. We're going to have to think about that later when we start parallel processing. So we need an attribute to group data by. Postcode is too precise. We saw that before. It creates several thousand parallel processes. That's not good. The first 3 characters might work. So what I'm going to do is I'm going to put a substring extractor transformer down. Sorry if I'm rushing through this a little bit, but we've got a little bit to get through and not long to go for the rest of the day. So I'm sort of rushing a little bit. I'm sorry about that. I'm putting a substring extractor down. I'm saying read the postal code attribute, wherever it is. Postal code, there we go. Start at character 0, end at character 2. So in other words, fetch the first 3 characters of the postal code and put them in an attribute called postcode prefix. That's what I'm going to call it here. Go into the building validator definition, find the parallel processing, turn it on, moderate should be okay. It's a bit awkward. We've got to click in there, then we've got to click back again because we now have to go back and tell it how to group our data. And we are going to do a group by, what did I call it? Postcode prefix. I'm going to start typing that in. There we go, postcode prefix. That's easier to find now. Okay. Turn off feature caching because feature caching isn't going to work with parallel processing. You can't cache data when it's in separate processes. So we're going to have to do without that. So we hit the run button and it's going to process that data. And instead of having one big process, it's now going to start sending data out to multiple processes. We can see the transporter things going on in the log. We can see the multiple processes going on in the task manager. So that is all good. And because we're testing each building separately, it doesn't really matter what group it gets sent to. It's not interacting with any other buildings. But if I look in the output doesn't look the same as it did before. If I query the output, we're not getting the same results as we did before. Again, I'm going through this fairly quickly now, but there's lots and lots and lots of unzoned buildings. How did that happen that all of these buildings are suddenly unzoned? Well, that goes back to this zoning data here. And this is an illustration of how parallel processing can be a little bit complicated, because we said group by postcode prefix. None of the zones have a postcode prefix, so they're not being used. They can't be grouped. So all of the groups that are grouped by postcode prefix are going off in one direction, and the zones is going into a different process. And so basically everything's coming back as 0 zones, because the zoning data is not in the same process as the buildings. It's in a completely different process because it doesn't have the postcode prefix. So we're going to have to sort that problem out. There's a few ways we can do that. The easiest way is to say, let's make sure that each parallel process does get its own set of zoning data. How can we do that? Well, we can read the data inside the custom transformer, and we read it not with a reader, which I'm going to click and delete, but instead we're going to read it with a feature reader transformer, which we should have used earlier this week. So going into the definition, we say we don't need that input port anymore, thank you. I put a creator transformer down. Again, apologies if I'm going a little bit fast. The key point here is that we're putting this transformer to read the data inside the custom transformer. And because it's inside the custom transformer, every separate process that gets started off will include this, whereas before that didn't happen. So it's a map info dataset of zoning. Where's the data? There we go, data, zoning. So yeah, that's the key point to take from this, is that this data set didn't have the group by, therefore it didn't appear in all of the groups. Therefore, to solve that, we're going to make sure that every group reads it. Now that is on the one hand slowing things down a bit, because every process that gets started is reading that data in. So we're going to read that data in once for every group rather than just reading it in once for the whole workspace. So this is a reason we could say, actually, that might not be that fast, but we'll give it a try. So I go back to the main tab. We've got group by postcode prefix, but that doesn't matter now because the zoning is getting read in every different group that's going to run. Now we're going to run it. It should take about the same time as before, but this time we'll actually get the correct results. And it's definitely parallel processing. I can see that going on. Now, since the initial workspace ran fairly quickly anyway, we might not have even bothered to do parallel processing. Just when we do it in a training course, if I have a workspace that takes 10 minutes to run, it's very difficult to do that as a demo in a training course. So we just do a workspace that's a little bit smaller just to get the concepts across, and that's what we're doing here. So It might not have run much quicker here, if at all, but the principle is the thing that matters. Now, the other thing we could do is we could mess about with the substring extractor and say, well, I don't know how many groups we got there, but maybe if we just did, actually, will it tell me the feature count? No, it doesn't tell me feature counts in there. So maybe if I just said the first 2 characters of the postcode, like the first 1 character isn't going to do any good because all of the postcodes in Vancouver begin with V. But we have V3, V6, V9, so maybe that will be a bit different. So it took 28 seconds to run before. Let's run it now. Now we're getting fewer groups because I sort of said only create it for the first 2 digits of the postcode. So we're getting fewer groups. Is it going to be any quicker? Is it not? I'm not sure. But really this, again, is illustrating the idea that, oh yeah, there you go, it ran twice as fast. So it's illustrating the concept that parallel processing is something you have to really think about. You can't just turn it on, pick an attribute and say, okay, that'll run faster now than before. It might run faster, it might not, but sometimes you have to put a bit of thought into it, maybe a bit of experimentation like this. But like I said, minimize the number of groups. So small amount of groups doing lots of processing is way better than lots of groups doing a small amount of processing. That's the inefficient thing. Lots of groups, little processing is really inefficient. So you just have to sort of think about how it's working, try and figure out your groups. Try not to have more than 1 group per core because that is going to slow things down as well. If you have 4 cores and you have 6 processes, then you're going to be fighting for processor time. So it's not always quicker to just say, oh yeah, I'd like to have 16 processes. If you've only got 2 CPU cores, you've got 16 processes fighting for those 2 cores. It doesn't make any sense. So it's something to think about there. Okay, so we have got loops to go through and we have the wrap up for the training course. We've got 5 minutes to go. So what I'm going to do is this. I'm going to do the wrap up now and just give you the final information about certificates and things like that. And then if you want to finish for the day, you can. But I'll also do the loops because a couple of people asked me if I could do loops especially. So I will do the loops. But I will do them after I've done the wrap up. And then if you don't want to stay for them, that's fine. So just to very quickly run through this course wrap up. Well, I mean, this is it. This is the end. This is day 5 of advanced desktop training. You've gone through all of this training. You probably did the basic one as well. So that's 10 days of training, even if it was only a couple of hours a day. And hopefully you've got a lot of information out of that. And you learned a lot and you're more confident now, I hope, in using FME. But even though your training's done, there's still a good supply of information and things to help you out as you use FME. So we're going to look at a few of those now. So one of the things is the Safe Software website. That's probably more marketing, sales type information. It's not so much technical. But it does have some interesting things like, say, you're trying to make a business case to use FME and things like that. You can find other information in here as well, like why FME. If I want to know more about FME in architecture, I can look on there. I can look at customer stories and things like that. So, I mean, it is useful at times, not for technical stuff so much, but anyway. What it does have is a link to the support team. So you can look under here and look under technical support, and you can either file a support case, you can do a search for more information. Live chat is offline, which is a pity because it's quite nice to be able to sit in training and say, hi, how are you today? This is just the training class calling. But yeah, so we've got live chat, we've got sort of online based support as well. So make use of that. It really is there to help you out whenever you need it. And of course, your local partner, if you're in a different location around the world. Very often you've got a partner that you'll have purchased through, and they'll have their own support. In fact, when you purchase from them, you're probably paying them a certain amount of money to carry out that support. So it makes more sense for them for you to go to your local partner if you purchased FME from them. Not because I'm just trying to offload everyone to their partners, but because it helps you get a relationship with them. If you're in a different country, they might be more familiar with your data formats than we might be, and so on, and things like that. You might have a relationship already, so consider looking for your local partner for support as well. The Safe Software blog, I like that, but then I write quite a lot of stuff on here anyway, but it does technical information mostly. There's a few sort of marketing and sales things like subscription pricing for government and so on. But generally it's more technical thing like test clauses for 2019, enterprise level automations for server in 2019, change detection, computer vision, parallel processing redesign for 2019, Kubernetes and FME server. So we do a lot of technical related blogs on here as well. So it's well worth going to safe.com/blog and signing up or to get notified about when there's new blog posts. So very interesting stuff. And of course, there's all the manuals and documentation that are available in the product and on our website as well. The other thing we have is an FME community, which we pretty much looked at before a couple of times. This is the FME community. There's various components to it. There's the forums where you can just go and look at questions that have been asked before. You can help answer questions as well. It's a sort of, what do you call it, Stack Exchange type thing where you can earn reputation and earn badges and things like that. And you help other people, they help you, and it's quite a good and quite an active community there. So please do check that out as well. They're especially good on how to do something questions. So how do I do a certain thing? They'll help you out. If it's a bug or a crash, then fine, come straight to Safe. But otherwise, the community is a good place to go to. The ideas exchange, I think I showed that briefly before. You can post ideas, you can vote on other people's ideas. A reader to read EXIF data, which I think we already do. Oh, okay. So we've got, if you read a photo, we'll read the EXIF data with it. But if you just want to read the EXIF data directly, I guess that will be a new idea. So you could go and vote that idea up if you're logged in, of course. You can suggest your own ideas, vote other ideas up. And we do implement a lot of these ideas. Like we should be able to sort by, we can sort by votes. Maybe I need to be logged in, but you can sort by the ones that have been released. There we go. So there's a list of the ones that are released. So we've got lots and lots of different things that have been implemented, like a PDF reader, help panel, wormholes, blah, blah, blah. So FME Home Edition, we implemented that after feedback from here, and all sorts of things. So if you do suggest ideas, there is a good chance they will eventually get implemented. And we have a knowledge base as well with all the articles, and the FME Hub, which is where you can download custom transformers and templates and things from. So yeah. So if you could give feedback to us, let's see, let's copy that link and paste it, chat it out for you. If you can go to this survey and fill in your feedback about the course, that would be really useful. We do value your feedback really highly, and we do make changes according to the feedback that you provide us. So please do let us know what you think about the course. If you want to do something a bit more private or a bit more extensive, you can always email us, train@safe.com. But if you fill in a feedback form, preferably now, if you've got a second, that would be great. We will mail out certificates to anyone who attended and is still here at the end of 5 days. So congratulations, everyone still online should get their certificate emailed out. Again, if you don't, then email us train@safe.com. And yeah, so after that, well, we're pretty much done. I will, like I said, I will go back and go through loops fairly quickly. So if you want to stay and learn about loops, then that's good. Otherwise, I know it's late. Thank you for staying this long and for staying the whole of the week. It's really a pleasure and a privilege for us to get to teach you all about FME and help pass on our knowledge that we have at Safe Software to our users, and try and make you all into these super users that really can use FME very quickly and powerfully and do amazing things. A lot of our users do some fantastic things and present them at the World Tour and at the user conference. So yeah, and I should perhaps mention that the FME World Tour is going on. So let me just chat that link out as well. A lot of it's done already for the year, but there are still a lot of places on the World Tour. The World Tour is where we send staff around the world to meet with local users, to do presentations, to get presentations from those users. And so it really is very worthwhile to attend. There's still a few to do in the Asia Pacific area, Australia, New Zealand. Yikes. Europe and Middle East. I think there's still a few: Austria, Belgium, France, Hungary, Netherlands. What else have we got? The United Kingdom. So, and there's a few more in Canada and as well. So if you're in any of those countries, check this out and see if there's an event coming up near you, because it's a really good one. But yeah, so if you need to leave now, then thank you for staying and goodbye. And it's been a pleasure being with you this week. So on behalf of SAFE, thank you very much. And for those people that are staying, let's have a look at loops. I will try and do this fairly quickly because, again, we don't want you to have to stay longer than you need to. So let me just find the bit on loops in custom transformers. Where are we? There's the manual. Custom transformers and loops. And loops sound really cool, but you very rarely need to use them in FME. And that really is true. It's a loop is when you're doing something again and again and again, and quite often it's like a do while loop or a for loop in a programming language. Like I said, you don't need to do it very often in FME. One sort of broad example or analogy, I guess, an aircraft coming into land, especially I've noticed flying into London, in the UK, you fly over and then they say, oh, the airport's a bit backed up, so we're going to fly around in a loop for a few minutes. So the plane goes around in a loop, and it goes around, it loops around Watford again and again and again and again and again, until eventually air traffic control says, okay, you're cleared to land. And at that point, they go and they land. So going around and circling the airport or Watford or wherever it is again and again is the action. You're doing that action until a certain condition is met, which is landing clearance. And the same thing happens in FME. The idea is that you're repeating a loop, repeating a section of workspace again and again and again inside a custom transformer until a certain condition has been met, and then you can exit that loop and continue on. So you need various components. You need to specify where the loop starts, you need to specify where the loop finishes, and you need to specify a condition that lets you finish. The other thing that often happens is you get a counter. Like, so if I said circle the airport 5 times and then land, I got to count those 5 times. So often in FME we have a counter counting how many times you've been around. So yeah, so actually those are two conditions. One is how many times you want to do the process, and the second one is how many times you've done it so far. So if I say loop the airport 5 times, then 5 is the number I've got to go to, and 3 might be the amount of time I've done it so far. So again, we're doing that in FME. We're creating an attribute that says like, this is a count of how many times we need to do this. Another attribute is a count of how many times we've done it. And then we just need to define where we're starting from and ending. So I'm going to open up my instructor workspace. And this one is going to be a fixed count loop. So what happens in here is we've got 2 input ports. One of them is the input where the features are coming in. The other one's an input that you loop. That's sort of the loop entrance, the loop starting point. So you could say this is the plane taking off. This is it doing its action. And then if it gets into a loop, this is the starting point of that loop. And so the processing data is what it's doing. The expression evaluator is saying, okay, let's go back. The attribute creator says we need to do this 10 times, and the counter says, oh, but at the moment we've done it 0 times. So it's like the plane's coming in to land. It says, okay, I've looped the airport once. Can I finish now? In other words, is the loop counter the same as the number of times I need to loop? If it's not, we have this option here that says loop back to there. That's the entrance to our loop. So this is the plane going round and round the airport. It's adding 1 to the counter every time. And when the counter finally hits the maximum number that we want, then it passes the test, then it can go out. So if I run this now, we should see, even though 1 feature came in, the feature count goes up to 10 because that 1 feature came in here and it looped around 9 times, and finally it met the condition and it exited. So if you want an example of a very, very basic loop, have a look in the instructor workspaces and look for the fixed count example, and you'll see how it works. And so that exercise, that example shows the loop counter starting at 0, the maximum loops, which is 10, the expression evaluator, which is adding on to the counter, and the final condition, which is says, okay, we're done. You can stop going around in circles now. And whatever you want to do inside your loop comes into this here. This processing of data goes on there. An example in the real world, there's a link to our blog there, where somebody wanted to put trees in a certain piece of land. So they had their piece of land, it was split up into several pieces, and they said, I want to plant trees in here until a certain density is reached. So what they would do, they would sort of say, well, this is my first tree, it comes in here, I process the data. Have I reached my density yet? I've not. Let's go around and plant another tree. Have I reached the required density yet? If not, let's go around and plant another tree. And that way they could count how many trees they needed to create a certain density in a certain piece of land. Now, it's important to notice that that is the same feature going round and round again. It's not groups of features going around, it's a single feature at a time goes around. You notice we've got some transformers that are group based, like, I don't know, the statistics calculator, for example. Okay, and as soon as I place that, it says, whoa, hang on a second, that's a group-based transformer. You can't put a group-based transformer in a loop unless this is an exported transformer. So you would have to export that transformer. For technical reasons, it has to be in a separate FMX file for it to work when there's a group-based transformer inside here. But even this, I mean, this is like total extreme edge. This is like some of the hardest stuff you can do in FME. It's the most uncertain stuff anyway for me, for sure. So once you start putting groups inside loops, it can get really, really complicated really quickly. So that's something to be aware of. And again, it's not something you need to do very often at all. So, but just be aware you might get that error message. And if you do, then look on our website, look in the knowledge base for information about what you can do, what you need to do to get around that. I'm not going to go into it now because it's like, I know this is the advanced training, but that's really advanced. So I'm going to sort of skip over that a little bit. And so we've got an exercise here, and really, I don't think I need to run through this exercise because it's not creating a loop. It's actually looking at a workspace that's already got a loop in it. The workspace is, let me open it up. So it's custom transformers exercise 6. And basically it's got a transformer in there called the list breaker. The list breaker is a transformer that appears on the FME hub. And if I right click and edit it, then I can see the definition, and I can see the definition includes a loop. Things are going on in here that are looping round and round. There's my loop around point. So it's going back to the looper input port. So for every time you place a loop, you specify where to go back to, which is there. You can, by the way, have multiple loops, nested loops, one inside of another, if you needed to. The tester is obviously testing for our condition. So there's that. The list indexer, that's presumably doing the work part because it says on the bookmark doing the work. The expression evaluator, I can see it's got a loop count transformer. You can see I prefixed all of my attributes with underscore attribute breaker and something else. So this is, whoops, that's counting the loop. And we're keeping a count of how many times we go around. We've got the list element counter. So we're doing something with a list. We're saying, how long is this list? Oh, there's 10 features in this list. So we'll loop around 10 times. And every time we loop this feature around, we'll pull a different list entry and do something to it. So that's what it's doing here. And basically what it's doing, if you run this translation, I should put it on there because I shouldn't really run it with caching turned on. So what it starts out with is a list of trees. That's actually a list. If we looked at there, it would show us a list structure, and it's converting those into attributes like tree species 0, tree species 1, 2, and so on. So this is basically breaking up a list into different attributes. So that's really what the exercise is all about. It's just looking at that workspace to figure out what it's doing, to run it, to see how it works, to see what the feature counts are, to understand, because if you can understand what that workspace is doing, then you can understand lists. But it's an illustration of how little lists are used in FME, that this is the only example I could think of that loops. Loops are so little used in FME. This is the only example I could find that had a loop in it, and I literally couldn't think of an exercise to give to you that had a loop in it that would actually make sense. So that's how rare it is to actually need to do a loop. There's ways around it for sure. So have a look at that workspace anyway. Have a look through the custom transformer. Any questions, do ping us train@safe.com and we'll do our best to answer them about that. But again, it's a very little used bit of functionality, loops. Really don't need to do it that often. Yeah, there was one more thing I was going to say, but I totally forgotten what it was, so it can't have been that important. So yeah, so again, oh yes, I know what I was going to say. Loops are quite fun for doing fun things with, just to just as an illustration, very quickly, if I put a create a transformer down, I create a polygon that's a square. Oops. So my create a transformer just creates some geometry. I'm creating a square. I rotate that square by, let's see, 15 degrees. And then I put this inside a custom transformer, which I'm just going to call art because it's an art project. So we rotate that, and I can say, let's put a attribute creator down, loop count equals 0. Oops, don't need the equals, just need to say 0. So loop count 0, we're going to rotate that, we're going to expression evaluator is going to overwrite loop count, and we're going to make it equivalent to loop count plus 1. So we're adding 1 to the loop, and I'm going to put a tester down that says, is loop count equal to, I don't know, 15, shall we say? And if it is, it passes to the output port. If it's not, then I'm going to insert a loop. Oops, I need to insert a new input port. We'll call it loop. The loop goes back to the loop start point. So that will go back to there. And that will, we don't want to use the attribute creator because that would reset our count. So basically we're saying go through this 15 times, and we're keeping a count so we know how many times it's gone around, and we rotate it every time. And every time we rotate it, I'm going to write the output as well, just so we sort of, you'll see why I do that in a second. So let me run this. Actually, am I writing it to anything? There we go. So I'm going to run this. And if we look through here, we got the feature came through, it looped around 15 times, it got rotated 15 degrees every time. And if I look at the output, hey, we have some very funky looking artwork there. And we can do all sorts of weird stuff. But this is, we had a big art movement going in on an FME at some point. So feature color setter, let's, whoops. Let's set it to a random color every time, and we'll go through it, I don't know, 15 degrees, I don't know, what, 24 times is that? What's 360 divided by 15? I can't remember, but there we go, that looks about right. So yeah, you can do really funky artwork like this, and you could rotate it, you could offset it as well, and it would look really cool. So anyway, so some people have fun doing that, and yeah, please feel free to do the same.